Hi, this is Andy from Adaptronic, and in this video I'm going to talk about the new engine protection functions that we have on the Select ECUs. So we listened to what people said they wanted. We also did our own research on different failure modes that we've seen, and also ones that we've caught and been able to avoid, and we've come up with this set of engine protection functions. This should cover 95% of applications, but still be simple enough to set up. Firstly, the way that we've implemented it is when the ECU goes into engine protection mode, it gives you a lower rev limit, rather than cutting all power to the engine at all RPM. So you can specify the rev limit here, and a typical value might be say 2,500 or 3,000 RPM. This means that if you've got say a slightly low fuel pressure, you can still move the car around, get it back to the pits or whatever. The protection mechanism is set the same as the overboost protection, so you can either cut fuel, ignition or both. There are 5 different failure modes that can be detected using this system. The first 3 are pressure related: oil pressure, fuel pressure and auxiliary pressure. To use any of these, you must use a standard Honeywell or Texas Instruments 0 to 150 psi, half a volt to 4.5 volt sensor. You can buy these from our online store, or they're actually the standard oil pressure sensor on the LS1 engines and probably the other LS engines as well. Now, a lot of people that have been asking about engine protection are already using the external 0 to 5 volt input on the ECU for some other function. So to be able to get this data into the ECU, what we use is the Innovate SSI4 module. This can take 4 0 to 5 volt inputs and feed them serially into the ECU. This can be daisy chained with the other Innovate products. So the correct sequence is lambda sensor, so LC2 or MTXL, into TC4, which gives you 4 EGT probes, into the SSI4, and then into the ECU. All of those parts are optional. To enable the SSI4 input, it's just enabled here in the software, and the software actually tells you the sequence to connect the boxes in. Now, the input mapping that we chose on the SSI4 module is input 2 is oil pressure, input 3 is fuel pressure, and input 4 is auxiliary pressure. There's a reason why we didn't choose channel 1, and that'll become clear later on in the video. Each of the SSI4 inputs is differential, meaning that you need to connect the ground on them as well. So if you follow this diagram, then that'll work for you. Once they're all connected, you'll see the oil pressure, fuel pressure and auxiliary pressure in the gauges window and also in the log file. It uses the same units that you've used for manifold pressure. So if you're using PSI for boost, then you'll see oil and fuel pressure in PSI as well. Note that you don't need to connect all of them, you just need to connect the ones that you want to monitor. So the first protection function is oil pressure. So you can enter 2 minimum oil pressure values, one for below 3,000 RPM and one for above 3,000 RPM. A more sophisticated system would enable you to do a map at lots of different RPM points, but again, we have to keep it simple for ease of people setting it up. Our mission at Adaptronic is to give customers control over their engines in their cars. So the simpler we can make it, the better, because the easier it is for people. So everything should be made as simple as possible, but not simpler. If you're not using the oil pressure function, then just leave those numbers at 0. You can also enter a minimum fuel pressure in this field here. Now, fuel pressure is differential, so it's measured between the fuel rail and the intake manifold. The fuel pressure sensor itself is a gauge sensor, and that's what's reported on the gauge window. It's the gauge pressure. So the ECU internally calculates the differential fuel pressure by subtracting the manifold pressure from the fuel pressure. And if that differential pressure goes below the minimum that you've set in this field, then that will trigger the engine protection and give you the lower RPM limit. For those of you not familiar with how manifold reference fuel pressure regulators work, there's an excellent article on the TurboSmart website here. The third channel we call auxiliary pressure, for people that just want to measure something else. Originally this was intended for people wanting to use water meth injection and worried about their pumps falling over or they're running out of fluid. So that's what this function's for. Again, it follows the same logic as the other ones. If the pressure falls below that value, then the ECU goes into engine protection mode and gives you the lower RPM limit. If a sensor fails, then you'll just see a dash in the gauge window and in the log file. That channel will also be disabled from engine protection. So this could mean that we either lose communication with the SSI4 or the sensor itself gives a voltage at 0 volts or 5 volts. When the ECU is in engine protection mode, you can hit the F11 button, and in the window at the top, you can see the reason why the ECU is in fuel cut. This also appears in the log file. And even if the fuel or ignition cut is very short, it appears in the log file for about another half a second, so that will help in diagnosing very short shortcut problems. The fourth protection function in the ECU is lean out protection. So this is very simple. The ECU just measures the actual AFR and subtracts from it the target AFR. And if that difference is greater than a value that you specify, then it says that the engine's leaning out and will go into engine protection mode. So you can specify whether it's half an AFR point for petrol, or 1.0 or 1.5 AFR points. And you can also select whether it happens immediately or if it has to be sustained for half a second. Note that to use this function you have to set up your target AFRs correctly and the engine has to be fairly well tuned, otherwise you'll get false positives all the time. The last protection mechanism is one that I haven't seen on any other aftermarket ECUs. I'm not quite sure why. The idea came to me one day when I was setting up my race car, which is a rotary with staged injection. Now at that time the plug on one of the secondary injectors wasn't making good contact, and I could see that in the F11 window because I didn't see 12 volts on that injector channel. Now of course the engine idled and started perfectly because it only needs the primary injectors to do that. But unless I'd checked it on the F11 window and seen the open circuit injector channel, the first I would know about it is that when I got on boost, the engine would lean out on one rotor, which could be quite expensive. On an engine without staged injection, so on a normal 4-cylinder turbo, you'd notice the problem straight away because it'd only be running on 3 cylinders, so you could then turn it off and find the problem. But on an engine with staged injection like a rotary, you wouldn't notice it until it was too late. So to use our last protection function, which is injection open circuit test, you just tell the ECU which injector channels you're using. Not all installations will use all the channels, so that's why we give you the option. But then when the injector output is switched off, the ECU just looks to see if the voltage is above a certain threshold, which indicates that the other side of it, the injector, is connected to 12 volts. And if it's not, for several successive measurement cycles, then it flags an open circuit error for that injector and gives you the lower RPM limit. Now in the log file and in the F11 window, it doesn't tell you which circuit is open circuit, but you can see that very easily just by looking at the injector voltages in the F11 window. Now the last function that we're going to discuss is something that I didn't really want to do, but enough people want to do it that we had to provide a solution for them. So this is for people who are using a wideband oxygen sensor which only has an analog output. The AEM ones are very popular, and if you're trying to use engine protection at the same time, then you can't use the serial output of the AEM and the serial output of the SSI4 at the same time. So what you can do is you can take the output of the AEM gauge and feed that into channel 1 on the SSI4. Now, when the SSI4 is manufactured, they configure channel 1 as an RPM channel by default. So we need to change that to be a 0 to 5 volt input instead, and you need to use Innovate's LM Programmer software to do that. Here's where the option is to change that. So once you've done that, then in the gauge window it shows you what channel 1 is reading as a voltage in millivolts, so you can use that to log any sensor that you want to. But if you want to use it for an oxygen sensor input, then you just need to select get the O2 input from the SSI4 instead of from the ECU input, and then the ECU will read it from there instead of from the input on the ECU pin. Now, one last word of caution. I seem to repeat myself a lot about this, but there are several different calibrations of the AEM gauges. They keep changing them from one gauge to the next. There are at least 3 that I've seen. So the first one is 10 to 1 AFR is 0 volts and 20 to 1 AFR is 5 volts. So for that one you need to select UA-Go 0 to 5 volt on spare input. The second one that I've seen gives you 0 volts at 8.4 to 1 and 5 volts at 19.4 to 1. So this is the one that's labelled AEM 0 to 5 volt. And the last one is half a volt at 8.5 to 1 and 4.5 volts at 18 to 1. And that's this option here in the drop down menu. If you don't know which one you have, then you need to consult the documentation that came with the gauge when you bought it, or if you don't have that anymore, then contact AEM and ask them for the calibration of the gauge that you have. The fact that there are so many different calibrations is one of the reasons why we prefer to get the serial data from Innovate, because that's a well-defined protocol and it's common between all their lambda sensing products. Thank you very much, and for any more information please go to adaptronicecu.com.